Okay, now unlike last time, this one's asking us to try and prove what the volume of the box is. So it says show that the volume of the box may be expressed as that, and then find the maximum value of the box. Now part B you can see is the exact same as before. Okay, you're taking your volume, which you're given, and we're going to work with it. It's kind of like in National 5 towards the end of the paper, and you maybe had your quadratics question when you were trying to prove something, and then you were asked to factorise it or use quadratic formula. It's basically the same as that. Now, part B is easy to access, okay? We can all find the maximum value of the box, volume of the box. You can decide if you want to do part B first, because it's almost like churning it out and getting your marks, and then we can go back and look at part A. I'm going to just work through my way through part A, but some questions I might do part B first, just depending on the level of difficulty. So, a square piece of card has square of X centimetres cut from each corner, right? So what does that mean? So that means these wee bits here are X, and each side is 30 centimetres, and these wee bits here are X. And open box is formed by turning up the sides, find the volume. Okay, so the volume of a box, we know, is length times breadth times height. Okay, so what is the length, the breadth, and the height? Well, the length and the breadth are going to be the same, because they're going to be our sides along here. So that's your length, and that's your length there, and they're going to be the same. Now, how do we get them? Well, the whole thing is 30. We're getting rid of the two x's, so it's 30 minus 2x. So our length is 30 minus 2x. Our breadth is 30 minus 2x. And the height, well, if you imagine what we're doing is we are folding up our x sides here, and that gives us our height, so it's x. Okay, we're going to multiply this out. Now what I'm going to do is I'm going to just leave the first one, and I'll multiply this by x. Okay, I'm going to multiply it through. Now remember, we know what the answer is. The answer is right there. 900x minus 120x squared plus 4x cubed. So we need to hopefully get that bit done. So 900x, good start, minus 60x squared minus 60x squared plus 4x cubed. And you can see that we have the answer that is required. Okay, now obviously if you can't get this answer, you just take it, and we work through part B, find the maximum volume, right? So the volume we know is this. We're going to differentiate it. You could do v dashed of x, you could do dv by dx, it's up to you. Didn't bring my power down. Okay, what's your rules for stationary points? We then set equal to 0. Now, when I say equal to 0, I'm going to put it in the order that, you know, we're kind of used to. Make your life easier. Look for a common factor. Our common factor is 12. So we'll divide everything through by 12. Okay, we're going to factorise it. Again, do any working you need to do at the side. So we're trying to make 75 and add to give us minus 20. So we're going to have minus 15 and minus 5. Bring them down. Okay, so we have two values for x this time. Now what we need to decide is what one of them gives the maximum value. So we need to do our nature. We have x. I wrote dv by dx, so I need to put that in there. You could write v dashed of x and shape. Okay, so 4. I'll pick 10 between the two of them, and let's just pick 16. Now again, we're going into dv by dx, which is this one here. Don't write down what the number is. You're just going to put it in your calculator. And you are just going to check what one gives us a maximum volume. So that's positive, that's obviously 0. Negative. And then we should obviously expect to get a positive at the end, but good to just double check. Positive. Okay, so what does that look like? So we've got 2 stationary points. So we're looking for the maximum. So we have a max one there, and we've got a min one there. So maximum at x is 5. But what's the question say? It says find the volume. So our maximum volume, we're going to sub it into our formula. So 900 times 5 minus 120 times 5 squared plus 4 times 5 cubed. And then again, you're going to chuck that in your calculator. And we get 2000. Okay, what are our units? Our units are in centimetres, so centimetres cubed. So part B will always be the same. Okay, so you're looking for a maximum minimum. Part A will give you the formula that you're working with, and it's just a bit of problem solving to figure out part A.